Today is the 10th of November 2023, and this will be our fifth transformation lesson, and we'll look at enlargements. Thank you very much to everyone who has been watching our videos. Okay, if you haven't done so already, please consider subscribing, following us, sharing and liking our videos. I'll really appreciate that. Okay, and if the account is not yours, please ask for permission from the account holder. In the comment section, you normally see please follow my notes/script. Okay, what it means is, for instance, this is x y to y minus x, that is 90 degrees. So if you are not watching and I'm explaining, you wouldn't get what I mean. Okay, that is 5 3, that is 3 minus 5. So if you hear 3 5, no, go by the script. Okay, thank you very much. Also, beware of scammers. Okay, don't fall for it. I'll recap. We've been doing a lot of work in transformation. Okay, and our last video we look at rotation examples and using the graph paper, and I improvised a tracing paper using the A4 because I didn't have a proper tracing paper. But hopefully I'll get a tracing paper and use one of the starters to do a proper rotation that you can see. But I think I did justice to it. If you watch it, you understand. Okay, watch the last video for recap. Our starter for today, towards a last lesson, I said you should update your flashcard with rotation formulas. Okay, now if you are rotating an object clockwise, okay, at 90 degrees, I said I'll come back and explain it. At 90 degrees, we saw it yesterday, we used a tracing paper, but there is a standard formula. Okay, so assuming the object in this form, like yesterday, you have the coordinate 5 3. Okay, when you reflect it, the new image, it becomes y minus x. So here your y is 3. So if you reflect it at 90 degrees clockwise, you will get a new image at x for 3 and y minus 5. Okay, so this is a standard formula you can put on your flashcard. And then anti-clockwise and clockwise at 180 degrees, because whatever way you do it, it will come to the same object. So xy will become minus x minus y. So if you reflect the point either anti-clockwise or clockwise at 180 degrees, the point 2 1, you are going to get minus 2 minus 1. For clockwise 270, xy becomes minus yx. So if you have the point 2 3, you are going to end up getting minus 3 2. uh anti-clockwise 90 degrees, so in the not in the direction of the clock, the other way round. XY will give you minus YX. So if you have the point 24, you are going to get minus 4 and 2. Okay, we've already said anti-clockwise and clockwise are the same. So xy will be minus x minus y. So 6 2 will be minus 6 minus 2. Anti-clockwise 270 degrees. Okay, all these are in degrees. Xy will become x y minus x. So if you have the point 1 5, it becomes 5 and minus 1. Okay, so I'm going to pause here for you to just have a look. Okay, there. So update your flashcard. It's good to know it, so that if you use a tracing paper and you are not sure, and with your protractor, and you are not sure that you got it right, these formulas can guide you. Okay, now we've been doing a lot of work today. We want to consider enlargement. Okay, I'll talk you through it and show you the graph I have for you. Let's consider enlargement today. Here we enlarge a shape about a given point, also known as the center of enlargement, with a given scale factor. So they'll give you a scale factor. Okay, so they'll say that enlarge this object times 2, or a scale factor of 2, or a scale factor of half. Okay, you can reduce it or increase it depending on the scale factor they gave you. So if the scale factor is greater than 1, it means you are going to get a bigger object. So if it's 1.52 and above, you are going to get a bigger object. If it's like half, you are going to get a smaller object. However, even though it's still smaller, it's still classified as an enlargement because you've reduced the object to a smaller image. Even though it is a smaller, you've reduced it. Okay, the original shape and the enlarged shape will be similar but different. Okay, so in enlargement, the original shape and the final image will be similar but different. One will be smaller than the bigger. If it becomes the same, that means a scale factor of 1, so you haven't done anything. So they're expecting it to become larger or bigger. Note, two shapes are similar means they look like each other but different sizes. Okay, that is enlargement. But congruent shapes means exactly the same. Okay, so if I have a square 2 by 2 and I enlarge it and I still have 2 by 2, it's the same size. Okay, they are congruent, so they are the same. Consider the enlargement on the graph paper, graph 1. So I'm going to show you what I have for you. So the first enlargement, I have drawn some graph here. I didn't use coordinates, so I'll show you. So look at it. That is my object, 1 unit on each side. With a scale factor 2, it becomes 2 units on both sides. So I've enlarged this object to this one with a bigger scale factor 2. The second one, this is 1 unit on both sides. It's still a square, but now I've used a scale factor of 3. So I've enlarged this to a scale factor of 3. The third one, it looks like a triangle. So I have 2 units at the base, and then 1, 2, 3 as height. And then I enlarge it to half the size with a scale factor half. Okay, and then the new image, I enlarge it with a scale factor 3. So you see 1, 2, 3, and then 1, 2, 3. Here I have like a rectangle, and then I've reduced it by half. Again, now I have enlarged it with a scale factor 4. Okay, so these are the image I have. So you can see it's been enlarged 4 times. So there, so 1, 2, 3, 4, and then that one, 1, 2, 3, 4. The last one, okay, I've enlarged this and reduced it into half, if you can see. And then I have it's with scale factor 4. I've drawn 4 sides of that using the graph paper. So this can be a question on the graph with the coordinates, and you'll be given to do. Now, the second example I have for you, assuming you are asked to find the center of enlargement. So here again, I have this graph to show you. So I didn't bring the coordinate, I just drew it out. Okay, so assuming this is your object A, B, C, D, and that's also your object A1, your new image A1, B1, C1, D1. Okay, now if I join A to A1 and I extend it a little bit more and join B1 to this B to B1, C to C1, D to D1, if it's on the graph paper and I extend it where the 4 lines meet, okay, it's my center of enlargement. So as you can see, because I've magnified it, the center of enlargement is there. On the other hand, I have this bigger shape and I've reduced it to this size. Okay, so now the first one, the center of enlargement is before the image. The second one, the center of enlargement, as you can see, is I have the shape and I have the image. I have the image. So I'm having my center of enlargement here. All I needed to do is to connect the object with the image, okay, and extend the line for all the 4 points, and that will be my center of enlargement. Now you can also have your center of enlargement inside the shape. So that is my first shape, yeah, and that is my image. Okay, so if I join this together, I have this point, and if I join all the corners together, they all meet there. So that will be my center of enlargement. So sometimes you can have the center of enlargement inside the two shapes. Okay, assuming you had your object and your image as this, or you can have the center of enlargement as in this case, where you have reduced your object to a smaller image, or you can have your center of enlargement somewhere before the object if you magnify the image. Okay, so today I'm just doing a short video on enlargement. Enlargement is fairly easy. They might ask you to enlarge it, give you an object, or you plot a point, enlarge it with scale factor 2. So you do that, and then you magnify it. Okay, or you multiply the coordinate and plot it, which will give you a bigger one. Okay, as I've shown you. Or after that, you'll be asked to find the center of enlargement. So today is just a short video to show you how to do enlargement. Okay, thank you for watching today's lesson, and I'll see you in the next.